Welcome to the introduction of the leakage current in the medical devices. In this video we will try to answer the questions like, what is mean by leakage current, what are the different types of leakage current, how leakage current can be measured, and what are the limits of leakage current as per the standards and as per the applied parts types. Leakage current is the current that flows through the protective ground conductor to ground. Leakage current is not functional. Most safety testing regimes for medical electrical equipment involve the measurement of certain leakage currents, because the level of them can help to verify whether or not a piece of equipment is electrically safe. Depending on the type of equipment, acceptable levels of leakage current have been determined and are generally outlined in the appropriate international or regional standards. Acceptable levels of leakage current are dependent on the classification of the particular type of equipment. Please remember that 2 levels of protection required for protection against electrical shock. Other terms related to the leakage current are as follows. Insulation Class 1 term referring to electrical equipment in which protection against electric shock does not rely on basic insulation only, but which includes an additional safety precaution in that means are provided for accessible parts of metal or internal parts of metal to be protectively earthed. Insulation Class 2 term referring to electrical equipment in which protection against electric shock does not rely on basic insulation only, but in which additional safety precautions such as double insulation or reinforced insulation are provided, there being no provision for protective earthing or reliance upon installation conditions. Patient connection is the individual point on the applied part through which current can flow between the patient and the equipment in normal condition or single fault condition. Protective earth conductor means any conductor to be connected between the protective earth terminal and an external protective earthing system. Protective earth connection is the connection to the protective earth terminal provided for protective purposes. Protective earth terminal is the terminal connected to conductive parts of Class 1 equipment for safety purposes. This terminal is intended to be connected to an external protective earthing system by a protective earth conductor. Protectively earthed is the connected to the protective earth terminal for protective purposes. Possible reasons of flow of the leakage current in the equipment are the voltage on the conductor, the capacitive reactance between the conductor and earth, the resistance between the conductor and earth. Different leakage currents are defined according to the paths that the currents take. There are several different types of leakage current, for examples earth line leakage, touch and chassis or enclosure leakage, patient leakage, and patient auxiliary current. Relation between the dielectric strength and leakage current is inverse. If the dielectric strength is more, it means resistance of the insulation is more, hence leakage current flows through the insulation is less. While measuring supply circuits, polarity of the supply is reversible and tests are conducted at both polarities. There are the general tests conditions. When we measure the leakage current as per the standard 60601-1, those conditions are as follows. Measure the leakage current in normal condition and in the single fault conditions, measure the leakage current with the highest rated supply frequency and with a supple Li equal to 110% of the highest rated mains voltage. Leakage current is different for different applied parts. Applied parts are the part of ME equipment that in normal use necessarily comes into physical contact with the patient for ME equipment or a ME system to perform its function. There are three types of applied parts, B, BF and CF. They are classified based upon usage, C being cardiac versus non-cardiac and F being floating or isolated from earth, ground. B-type applied parts are non-cardiac grounded applied parts. These are applied parts that come in contact with the patient for the medical device to perform its function. B-type parts are referenced to ground and are not isolated or floating. F-type applied part is an isolated to such a degree that no current higher than the allowable patient leakage current under a single fault condition flows into it from an application of external voltage source to the patient. F-type applied parts are classified as BF means non-cardiac floating applied parts or CF means cardiac floating applied parts. Type CF applied part provide the highest degree of patient protection. This is achieved by increased isolation of the patient connection from earthed parts and other accessible parts of the ME equipment, further limiting the magnitude of possible current flow through the patient. Type CF applied parts are suitable for direct cardiac application. Earth leakage current is the current from all earthed parts of the product. Current flow through the mains supply to protective earth conductor. This is the measurement method of the earth leakage current. Earth leakage current limits for normal condition is 5 mA and single fault condition 10 mA. These limits are applicable for all applied parts. Multiple socket outlet is one or more socket outlets intended to be connected to, or integral with, flexible cables or cords or ME equipment for supply mains or equivalent voltage. If the ME system is supplied from multiple socket outlet, then earth leakage current of the multiple socket outlet shall not exceed 5 mA. Enclosure leakage current is also called as touch current. Leakage current from the enclosure or other parts, excluding applied parts that are not connected to a protective earth conductor, is called enclosure or touch current. This is the enclosure leakage current measurement method. Limits of the enclosure leakage current for normal condition 100 microampere and single fault condition 500 microampere. These limits are applicable for all applied parts. When the enclosure do not have a conductive part and we want to measure a touch current or protective earth resistance, for that wrap the metal foil to the equipment and take the readings. Patient leakage current is the current flowing from every individual part of the applied part back to earth, or the current flowing from an unintended appearance alpha voltage on the patient back to an F-type applied part. This is the patient leakage current measurement method. Patient leakage current limits for type B and BF applied part in normal condition 100 microampere and single fault condition 500 microampere. For CF applied part in normal condition 10 microampere and single fault condition 50 microampere. Special test condition is the test with maximum mains voltage on a non-protectively earthed accessible part. In patient leakage current measurement, we measure the current also in special test condition. Special test condition is the condition which is neither a normal condition nor a single fault condition. When caused by an external voltage on the patient connection of an F-type applied part, then patient leakage current limits are as follows. For type B F applied part limits is 5000 microampere. For type C F applied part limits is 50 microampere. When caused by an external voltage on a metal accessible part not protectively earthed, then limits of patient leakage current are as follows. For type B applied part limit is 500 microampere. For type B F applied part limit is 500 microampere. For type CF applied part no limit. To maintain a medical device's high level of protection during its operational life, a number of design features are taken into account to maintain the integrity of the device's electrical safety. This is done by introducing conditions that could occur under normal use, that is, reversed mains supply or voltage on signal input or output terminals, it also called SIP or SOP, and conditions that can occur under a single fault condition, that is, SFC. EX 60601-1 specifies a number of single fault conditions. EX 60601-1 specifies that all leakage measurements should be carried out using normal and single fault conditions. A typical part of the electrical safety testing procedures is to perform the test like as normal supply voltage no single fault condition, normal supply voltage open neutral, normal supply voltage open earth, reversed supply voltage no single fault condition, reversed supply voltage open neutral, reversed supply voltage open earth. Other signal fault conditions are signal input or output terminals, that is, communication ports such as USB or RS-232, mains voltage on floating, that is, F-type applied parts, failure of electrical components, failure of mechanical parts, failure of temperature limiting devices, shorting of basic or supplemental insulation, overload of mains supply transformers. Single fault condition occurs one at a time. SIP or SOP, that is, signal input port or signal output port, is the part of the medical product that is not an applied part but is intended to send or receive signals from other external equipment. If mains voltage is accidentally applied to a signal input or output part due to a fault in the external equipment, then there is effect on the leakage current. So, if SIP or SOP part is available to the equipment and equipment has the F-type applied part, then leakage current is measured in special test condition. Patient auxiliary current is the current flowing between patient connections and, that is, not intended to be there to produce an effect in the patient. This is patient auxiliary leakage current measurement method. Patient auxiliary leakage current limits are as follows. For type B and BF applied parts, in normal condition 100 microampere and single fault condition 500 microampere. For CF applied part, in normal condition 10 microampere and single fault condition 50 microampere. Total patient leakage current is the vector sum of the individual patient leakage currents with multiple functions or multiple applied parts. The total patient leakage current could be much higher. Total patient leakage current limits are as follows: for type B and BF applied part, in normal condition 500 microampere and single fault condition 1000 microampere. For CF applied part, in normal condition 50 microampere and single fault condition 100 microampere. Thank you for your time.